And yesterday we talked about extrema, absolute minimum, absolute maximum on a interval. We're gonna continue with that. So let's talk about local extrema. Another word for local extrema is relative extrema. And some of you may or may not remember from last year. Remember, we used to talk about absolute max, relative max, absolute min, relative min. Okay? So, let's talk about minimum. The absolute minimum is exactly what the name suggests, that there is no value smaller than that number. It is the lowest value that that function attains. A local minimum it just means that there is no smaller value of f nearby. Okay, these are the official definitions. Unofficially, like de facto basically, the very, very lowest, okay, point is the absolute minimum. All others are relative minimum. The very, very highest point is the absolute maximum. All others are relative maxima. So a function could have, let's say there are 5 maxima. You know, the highest one would be the absolute maximum. The rest would just be relative maxima. Okay? So every time you have a peak or a valley, that could qualify as a maximum or a minimum. The very lowest is absolute, the very highest is absolute. Okay. Local extreme values. If a function has a local maximum or a local minimum value at an interior point, that means f prime of c is equal to 0. So basically, at an interior point, at an interior point, the minima and maxima happen where there is either a trough or a crest. Okay? So anytime something changes from increasing to decreasing, decreasing to increasing, in other words, every time you have a peak or a valley, that's where you have a minimum or a maximum, and at those peaks and valleys, f prime is equal to 0. And I need you to know that like you know your name. Every time you have a peak, every time you have a valley, this is where f prime of c is equal to 0. F prime of c is equal to 0. Okay? All right, how to find local extrema. All right, first find the domain. Okay? Next, find the critical points. We did that yesterday, right? How did we find critical points? It was either where? Where the derivative equals 0 or where it's undefined. Right. No, the critical points are, right. Yeah. So make sure the critical points are in the domain. So if you're looking at a domain of like -3 to 5, and x equals 10 is a critical point, you throw that away. You just want the critical points in your domain. Most of the time you will be. Or if you're not, then if it's like a domain of all reals, then it all works. Okay. Create a number line for f prime of x. Label the critical points and any end points. Critical points and endpoints. Okay? Okay, this is a like a tip or like a trick of the trade. It's helpful to put open circles at any points that give you discontinuities. Okay? Okay, using the number line, we have to test values, so we have to plug we have to plug values into f prime of x, label the number line with a positive where you get a positive value, negative where you get a negative value. So now let's think about this. So f prime is the derivative, right? What's another word for derivative? Slope. If f prime, which is derivative or slope, is positive, what does that mean about how the function looks? Is it increasing or is it decreasing? It's increasing if f prime is positive. It's decreasing if f prime is negative. That's how we're going to do this. Okay? So, if something changes from a plus to a minus, from an increasing to a decreasing, there is a maximum there. If it changes from minus to plus, there is a minimum there. To find the actual max and min, plug in the values back into the original equation. Okay, you had a question.
On the page before, what's f prime of c that equals 0? Like which one?
If there is a local, c is the x value where the peak or valley happens.
Oh, okay.
Right? So like this is c, let's say, where there is a peak or a valley, f prime at c is 0. It's a horizontal.
So does that fit into the steps? We have to do that in the steps.
You're sort of doing it when you find the critical points.
Oh.
Those are the c's where f prime is 0. So I know this is a lot of steps, and it might sound overwhelming, but once you start doing it, it just flows. So let's start from the first one. It says to find the domain of the function. What's the domain of the function? I know they're not giving it to you, but the domain of this actual function is what? It's a polynomial function. It's negative to positive infinity. Because okay, so are there any values of x that might not work in this function to give you a real number? No. Okay, so now we need to find the critical points. To find the critical points, we're going to take a derivative. It's going to be 3x squared plus 2 times 3 over 2x minus 6. So f prime of x is 3x squared plus 3x minus 6. To find the critical points, we want to set this equal to 0, right? So we're going to do 3x squared plus 3x minus 6 equal to 0. Can we divide? Yeah, what can we factor by? 3. So we get x squared plus x minus 2. Now this is 3 times x plus 2, x minus 1 equal to 0. Now, for what values of x then is this going to be 0? X equals
3, negative 2, and 1.
X equals negative 2 and 1.
0.
No.
Okay. Okay, I purposely left the 3 in front of the equation. The 3 is just a constant. It's not a variable. So you disregard it. It doesn't make a difference because you can potentially divide both sides by 3. The 3 goes away. So when you factor like this, and when you have a constant, a number in front, it does not factor into the zeros, right? So you just get the zeros from the variable.
Could you have anything that you can just divide by x plus 2 on both sides?
No, you can't divide if you have a variable. Mathematically you can, but you're just getting rid of information. You're changing the problem. Okay, so those are the critical points. Okay, now, what was the next step?
Number 1.
Create a number line. So let's create a number line. And it says to put the endpoints. It says to put any endpoints. Are there endpoints in this problem?
No.
No. So we just put in negative 2 and 1. Now,
So the endpoints would be in the domain that they gave you?
sometimes they would sometimes they will give you the endpoint. So let's say they would say f of x blah 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 over the interval negative 3 to 6 or whatever. Okay, now we're going to test points from each region. Okay, you see how you have 3 regions here? Okay? What's the number in that region? -3. We're going to plug -3 into the original, into f prime of x. F prime of x is where? This.
Wait, why not the original?
Because this is for f prime. We want to see if f prime is positive or negative. So we're going to plug the numbers into f prime. Now, you can plug it into this, or you can plug it into the factored form. I find that sometimes it's easier to plug it into the factored form. So let's do that. Are you done? Okay.
I thought one. Wait, on this budget, what does the MM stand for?
Huh?
On the bottom.
2018.
Roman numerals that say 28. No, not the Roman numerals, the M. Wait, turn around. Yeah. Yeah, Roman numerals.
M is Roman numeral for 1,000.
Okay, so we're going to plug -3. I'm going to plug it into this. Okay, I'm going to plug in -3. When I plug in -3 into the x in the
Why
first
-3?
Why have to finish it, right?
Okay, hang on. Listen, when we plug -3 into the first parenthesis, that gives me a negative number, right? Right?
Yeah.
-3 plus 2 is negative. When I plug it into this, that gives me another negative.
Yeah.
So it becomes
Negative,
positive.
negative, this is positive. Next,
Oh, we did this like 2 chapters ago.
Now we could do 0.
next plug in 0. First parenthesis gives me positive, then negative, so it's negative. Plug in like a 2, I get positive. Okay? So this is f prime of x. F prime of x is positive, negative, positive. F prime is derivative. What's another word for derivative?
Slope.
Slope. So here slope is positive, negative, positive. If slope is positive, what's
the
the
max.
function doing?
It's
Going up.
max.
It's increasing.
Peaking.
So now we say,
Full max.
this is increasing, decreasing, increasing. So f of x is increasing, decreasing, increasing. That means, like you guys said, there is a maximum here, there is a minimum there. Well, no, it's increasing indefinitely, like up to positive infinity. Okay, so here, it's going up to positive infinity. It's increasing forever. And here it started from negative infinity. Okay? Now, the next step is, the last step is, we actually want to find, okay, fine, there is a maximum there. At x equals -2, there is a maximum. But it's -2, and what's the y value? Now that's what we need to find.
Oh, so that goes in.
That goes in the original function. Plug into original function. So, maximum, yeah, it sounds a lot worse than it is. Maximum, f of -2 is equal to how much? It's 11. And minimum, f of 1 is -2.5. Okay? Yes.
How did you get when you plugged in x equals -2 and 1? When you plugged those into the one above it, how did you get -2? How did you get like the values you got?
11. How did I get 11?
No, like when you were doing that step back there.
This?
Yeah.
How did I get these?
No, the one above it, like the one circle.
This.
Yeah. You were creating your number line and you're plugging -3, 0,
Okay.
and anything.
I plug -3 into this, right? -3 plus 2, does that give you a negative or a positive answer?
Negative.
Negative. Here, -3 minus 1. Negative. Negative makes positive.
Oh, I see. So it's not about the 3 at all.
No, yeah, it's not about the 3 at all. You could have done -10 and it would have been the same.
Okay.
Okay? So this is how we can do this. So now you can actually graph this function like to the T. You could graph this function because you know where the zeros are, you know where the maxima are, you know where the minima are, and you can graph this with no help from your calculator whatsoever. Okay? All right. So let's do another one. Okay, so what's the domain here?
Not equal 1 or negative.
Awesome. So it's negative infinity to negative 1, 1 to infinity. No, I missed one. Negative 1 to 1, 1 to infinity. Okay, that's the domain. All right, now let's find f prime of x. And you know what? I'm going to do the quotient rule just because I miss it. Okay, let's do quotient rule. So low d high, take high d low, cross the line, and then we're going to square. So f prime of x is negative 2x over x squared minus 1 squared. Okay? Yes? Okay, so
Couldn't you make that into like x to the 4th plus 1?
no. It'll be x to the 4th minus 2x squared plus 1, but there is no need to do that. We could just leave it that way. Okay, critical points. Critical points are where the function equals 0. When you set it equal to 0, you would get basically the numerator equal to 0. So if the numerator equals 0, what would x equal? 0. So x is 0. And then from the bottom, what are the critical points? X equals plus or minus 1, right? Because you have to find all the values where the function is 0, where f prime is 0, or it's undefined. Okay?
Why is it 0 again? X equals 0?
Because if you set that entire function equal to 0, okay? Cross multiply, negative 2x equals 0, x is 0. Okay, so now, let's do, okay, so those are the critical points. By the way, these critical, okay. Is x equals plus or minus 1, are they in the domain?
No.
No. So not in domain. So technically, just like Pluto got demoted, they get demoted from being critical points. Okay? Because the domain is, don't worry too much about it because we're going to end up putting it in the number line anyway. Okay, so let's put it all in the number line. We need a bigger number line for this.
Wait, I still don't understand why it wouldn't be in the domain though.
Because at negative 1 and positive 1, it doesn't exist, right? It's undefined. It's not in the domain. Don't worry too much about that part. Okay. Worry about this. So look, we're going to put all the numbers in there anyway, right? Negative 1, 0, 1. Okay. Now remember what I had said above here? Put open circles at the discontinuities. So we're going to put open circles here. Okay. Now, yeah. Okay, now. Let's pick a region. Yes.
So for these problems, are there 3 answers? Just the critical point, the number line, and then the minimum maximum? Or
Technically, you're looking for minimum and maximum, but when I grade, let's say this will be like an 8-point problem. And you will get 1 point, for finding the correct derivative, 1 point for finding critical points, a few points for the number line, for plus and minus, and so on and so forth. So you need to show me all of it. Okay. So listen to how we're going to do this. We're going to pick a point from the leftmost region. Let's say negative 2. Now, let's be wise and efficient about this. We're going to plug it into f prime of x. The denominator of f prime of x is the whole thing squared. So no matter what you plug in there, it's going to be a what? Positive. So I disregard it because it's not going to give me any new information. Therefore, when I'm plugging in numbers, all I care about is the numerator. So when I plug negative 3 in here, do I get a positive or a negative? Positive. How about when I plug in like negative 0.5? Still positive. So it's going to be positive positive. What about 0.5?
Negative.
Negative, negative. So that means f of x is increasing, increasing, decreasing, decreasing. So there is a maximum right there.
So you only have a max.
You only have one
So
maximum.
when it changes, you have a max?
Yes.
So that's a parameter.
Maxima and minima occur when the function changes between increasing and decreasing. Isn't that cool?
So then the minimum would be on the right then?
Nice.
There is no minimum. Minimum would have been when it was changing from decreasing to increasing, but that never happens. There is never a place where it changes from decreasing to increasing.
Right.
So maximum is f of 0, which is what? Negative 1. There is no minimum. There is no minimum.
Wait, but is this the local?
Yes.
So then,
Yes.
so this
Okay.
is absolute maximum. Should we not say absolute maximum? Unless we know for sure it's the absolute maximum, should we not?
Yeah, just say maximum. You're
Is
fine.
that the absolute maximum because there's no other next to it?
Okay, so this is a debate. Domain here.
1 to 1?
Well, no.
Negative
Well,
infinity to 1.
Negative infinity to
1 positive infinity.
right, but and 1 is included, so it's just negative infinity to infinity. Okay? Okay, now f prime of x, right? How are we going to find f prime of x here? Well, just like we did it before, you just do the derivative of the first function, the derivative of the second function. So of the first function, it'll be negative 4x. Of the second function, it'll just be 1. Now, this x is less than or equal to 1. You're not allowed to say less than or equal to. It's just going to be x is less than 1 and x is greater than 1. Remember when we were graphing like a derivatives, it was always open circles.
How does that work if it's just there that if it's greater than 1, then why is it greater than 1?
It's 1 plus
No,
1.
the derivative is the slope.
Oh, so
The slope is 1. The slope is 1 for all x's, like after x equals 1, the slope is 1. It's not the value, it's the slope. Okay, so now what are the critical points here?
wouldn't it just be 1 and 1?
Okay, there is x equals 0, right? Because you set negative 4x equals 0.
1.
So x equals 0, that's a critical point.
Wouldn't it be 1 also because because it'd be undefined? You know, it would be 1 over
It's just a
0.
constant though.
Just be 1, right? Because it still can be. I mean,
There's no x, so you can't make it.
Yeah.
And then the other one wouldn't
so
be 1.
But now, this is a special situation, okay? So, we want to check for a corner.
Oh, I hate corona.
Okay, so check for corners. Now, okay, at x equals 1, right? That's x equals 1. I don't want to. Okay, at x equals 1, to the left of it, okay, the slope is negative 4x, right? So when you plug 1 in there, what's the slope?
So it's not differentiable.
M equals negative 4 below it, okay? What's the slope here? Right after it,
1.
M equals 1. So the function is changing at x equals 1. Now, if you look at the slope, immediately to the right, m equals 1. Immediately to the left, m equals negative 4. So here, the slope is changing.
Oh, so it is a corner.
Yeah, the slope is changing instantaneously from negative 4 to 1. Okay? So that is a corner.
Does that change like the
Yeah.
curve?
Yeah, corner at x equals 1. So that's another critical point. So now we have 0, 1. All right, let's plug a number less than 0 into f prime. Okay?
-2.
Is it positive or negative?
Which one are we plugging?
-2.
Okay, so we're going to plug in a number less than 0. That's in this region. So how much is it going to be? Positive. How about like a
0.5.
a 0.5?
Negative.
We don't need to show you the work of finding positive and negative, right?
No. And then here it'll be positive.
Positive.
Oh, because it just won't.
I got it.
So increases,
You know, tell me.
decreases,
Oh, I see.
There's two maximums.
So you actually
Increases.
use the piecewise function to guide where you're.
yes.
Wait, how is that positive?
There is a maximum and a minimum.
If it's
When
a
you-
positive number times a negative number.
No. Since it's past 1, you use the little one on the bottom.
What?
Yeah.
So maximum f of 0 equals how much?
5.
5. Minimum
What? Oh, wait.
f of 1 equals,
Let me just be 1.
would it be 1? We're going to plug it into f of x. F of 1 falls into, right, 5 minus 2
I was looking at that.
equals 3.
How did you get 5?
Yeah, how'd you get 5?
Because you plug f of 0 into the function here.
How come you put it in the top one, not the bottom one?
Because it's
Wouldn't it need to be squared though?
less than or
The
equal
bottom one
to
doesn't exist.
Oh.